specialized agency of the ECO, and with its 10 member countries, including Afghanistan, Azerbaijan, Iran, Kazakhstan, Kyrgyz Republic, Pakistan, Tajikistan, Turkey, Turkmenistan, and Uzbekistan. So I'm the moderator for today's session. Before we begin, I would like to make an announcement that I would like to request everybody, all participants, to keep your microphones off all the time. And I would highly encourage that if you have any questions, please put in the chat box and we'll take them at the end during the Q&A session. So once again, on behalf of ECO Science Foundation and the Union of Iranian Societies of Mathematical Sciences, UISMS, I'm delighted to welcome you all to a lecture series on popularizing maths and science. So today we are fortunate to have Professor Dr. Allaberen Ashyralyev, distinguished mathematician, as our esteemed speaker for today's webinar. Just a brief background of Professor Ashyralyev. He's originally from Turkmenistan. He earned his PhD from Voronezh State University and his doctorate of sciences from the same university with the Institute of Mathematics of the Ukraine Academy of Sciences. Dr. Ashyralyev has served at a number of institutions, at a number of countries. So he was a visiting scholar at the Voronezh State University, Russia. He also served at the University of California, Santa Barbara, USA. He continued his career at Turkmen State University, progressing from assistant professor to till professor in 1995. And later on, Professor Ashyralyev was also awarded the title of Master Teacher of Turkmenistan by the Ministry of Education, Turkmenistan. Professor Ashyralyev has also been a staff member of Department of Mathematics and Elementary Mathematics Education at Fateh University, Turkey, and a visiting professor at the International TTU, Turkmenistan. He has also been a visiting professor at the Institute of Mathematics and Modeling at Almaty, Kazakhstan, and also at the People's Friendship University of Russia. Recently, Professor Ashyralyev has been associated with Department of Mathematics Near East University in Cyprus, and he has also served as the head of Department of Mathematics Education at Atatürk Education Faculty. Since November 2021, Professor Ashyralyev has been a staff member of the Department of Mathematics at Bahçeşehir University in Istanbul. So his title of talk is Boundness of Functions of Positive Operators and Their Applications. So that's the brief introduction about Professor Ashyralyev. Now the floor is open to you, for you, Professor Ashyralyev. Over to you, please.
Okay. Hello, everybody. First of all, I would like to say great thanks to organizing committee for inviting me to give a lecture on the lecture series Population Mathematics of Sciences, especially to Professor Khalil Raza, Program Manager, Energy, Climate, Economic Corporation, Science Foundation. Secondly, organizing such type of activity is not easy, but very important, especially for young sciences. Therefore, I wish great thanks organizing committee in future. When I get invitation such type for my talk, first of all, I also have some difficulty for choosing subject, but after sometimes later I understand, maybe find some general concepts useful for mathematician, also maybe people from maybe engineering sciences. So I choose here boundness of functional positive operator and their applications. My choose connected with finding of some algorithm for solving problem such that arise usually applied sciences, but such object like partial differential equation. And also this techniques useful for algorithm, useful also for investigation numerical aspects, such type of problem, also realization. So the general idea maybe for solving such that arise in our investigations. So abstract in this discuss abstract operator approach for solving partial differential equation in modeling of process engineering and technology. So, as you know, various local problems for partial differential equation can be reduced to local and non-local problems for ordinary differential equation in Banach space with unbounded positive operator. And investigation boundedness of function of operator important for different aspects, and I will talk about it. And here application of getting results to partial differential equation considered. This online we will give definition of positivity in Banach space. After that, we will talk about definition of function of positive operator Banach space and applications. And later, I will invite young people for joint work online in future. Partial differential equation governed many phenomena that happen in natural and play important role in the modeling of process of engineering technology, essentially of the fundamental partial differential equation very difficult to solve explicitly. The studies of well-posed and ill-posed classical, non-classical problems, boundary value problem, partial differential equation are driven not only by theoretical interest, but also by the fact that several phenomena in engineering, various fields of applied mathematics, can be modeled and investigated in this way. But usually classical way, integral transform, useful all the special case when coefficients not dependent special variables and time variables. So investigation problem when coefficients dependent special variables is important. And classical, non-classical problems for partial differential equation, we can write, as I said before, as problems for ordinary differential equation Banach space. These techniques arise maybe, how I say, 80 years before in sciences, 16 years, and directly use it for investigation partial differential equation. And when no way to use it, classical techniques for solving differential equation use it operator approach. And in these cases, we will find some way to see our object as ordinary differential equation in some spaces with unbounded operator. And it is important to see a property of this unbounded operator. And here we will start with positivity definition. The operator A is said to be positive if it is spectrum sigma lie of A lies interior of sector of angle symmetric with respect to the real axis, and if on the edges of the sector S1, S2, and outside of resolvent is subject to the bounded and estimate one satisfied. The infimum of such type angles phi is called spectral angle, and this spectral angle depended with operator A and spaces E, Banach space. The operator A said strongly positive in Banach space E is if spectral angle less than pi over 2. And here, feature, you can see okay, here examples. First example, everybody know about self-adjoint and positive definite operator in Hilbert space. This is one good example for positivity, and first self-adjoint positive definite operator spectral angle equals 0, and why we will see positivity, this definition as the generalization of notion positivity in Hilbert space, because in Banach space no way defined norm within a product, so we need some maybe generalization like that. Second, differential operator, second order minus second derivative plus sigma u tilde, sigma positive, and domain u, and second derivative from CR1. This is a continuous bounded function on defined on R1. Strong positive spectral angle less than pi over 2. And third operator, first order differential operator with domain U and first order derivative from CR1. This operator, first order operator, not strongly positive operator. It is angle greater than pi over 2. The theory of positive operator can be constructed for wide class of positive operator. I give here as a reference monograph Krasnodębski, Zabryga, Pustilnik, Sobolewski. Method of positive operator as a tool for the investigation of the solution partial differential equation in Hilbert and Banach space has been systematically developed by many others. It is well known that various classical, non-classical problems can be reduced local, non-local boundary value problems for differential equation in Hilbert space, Banach space. The role played by the positivity property of differential and difference operator in Banach and Hilbert state of various property of boundary value problem for partial differential equation, stability of high order accuracy difference schemes for partial differential equation, and summability theory. As a reference, I give here some reference here. Important progress has been made in the study of positive operator from the viewpoint of stability analysis of difference schemes for partial differential equations. It is well known that the most useful methods for stability analysis of difference schemes are difference analogy of maximum principal energy method. The application of theory of positive difference operators allows us to investigate the stability and coercive stability properties of difference schemes in various norms of partial differential equations, especially when one cannot use the maximum principal energy method. Moreover, structure of functional space generated by positive differential and difference operates and its applications to partial differential equation has been investigated by many researchers. Finally, surveys of results in functional space generated by positive operator and the applications to partial differential equation has been in the paper. So, second chapter, we will consider function of operator in Banach space. It is well known that continuously bounded function on R1 self-adjoint linear operator with denser domain in Hilbert space. The following integrals, the spectral representation formula holds for, where E lambda is a spectral family associated with A. The Riemann-Stieltjes integral is to be understood the sense of uniform operator convergent. Such way defined cosinus t square root of z, sinus t square root of z, and exponential minus I tz, I here complex number, for all tr and self-adjoint positive operators. It is investigated in the these classical books, Cranes and Hector Fatarinus. So as I say, classical, non-classical problems, hyperbolic equation can be reduced to local, non-local problems. Problem 5, this is Cauchy problem for hyperbolic equation, and many problems involve such type ordinary differential equation. Second, delay, nonlinear delay equations, Cauchy problem, initial value problem for nonlinear delay equation. And problem 7, here hyperbolic equation damping terms, and in literature call it telegraph equations, delay case. And problem 8, here multi-point non-local boundary value problem. Here n multi-point point. And problem 9 here, non-local problem with integral conditions. And last problem 10, involutory problem. So differential equation with involution very important in applications and not easy to study theoretically. I formulate here as a problem 10. But for maybe consider here, we will start simpler case, problem 5, Cauchy problem for hyperbolic equation. And usually here we will consider classical solution, and solutions means if satisfied 3 conditions here. Must be here where of t continuously differentiable on the segment, and where t must be from domain of t for any t, and a where t must be continuous, and where t satisfied equation 5. And if data satisfied some smoothness condition, and we can write formula 11 using by formula for function of positive operator. And here I formulate results under the smoothness condition. We have stability results for the solution and stability results also high order derivatives. But this theorem I cite from our monograph joined with Sobolevsky 4, but really it is very early results, Pogorelenko, Sobolevsky, and 50 years before. But here I will consider a simpler example how we applied these results for investigation problems. Consider problem hyperbolic equation non-local conditions. And problem 13 has unique solution for the smooth functions, and when and they are satisfied, these smooth functions satisfied compatibility conditions. And we will put normally condition for dependent coefficients x must be positivity, and also here, as we see here, no local problems must be here condition a L equal or the A of 0. Periodic condition, and delta must be positive. And we will formulate here stability results in the term of normal norms, L2 and C with respect T, L2 with respect X. This approach, operator approach, allows us to prove the stability wide class problems, linear, nonlinear hyperbolic equations with dependent coefficients. Moreover, high order accuracy two-step difference schemes generated by exact difference schemes or by the Taylor's decomposition on the 3 points for the numerical solution of this problem were presented. The stability estimates for the solution of these difference schemes are established. In applications, the stability estimates for the solution, high order accuracy difference schemes of mixed type boundary problem for hyperbolic parabolic equation were obtained. Here I give some reference here, usually PhD thesis, my students in this subject. So first PhD thesis, we will consider problems such that arised from exploitation of natural gas. When we see here mixed type of differential equation, hyperbolic parabolic equation, we will consider here theory of differential equation, and also we constructed here absolutely stable difference schemes, and we will consider here some applications. A second thesis, important thesis, when hyperbolic equation depended with T coefficients, not easy construction investigation, high order accuracy difference schemes. And we know before only first order difference schemes, and this thesis we will construct it second order difference schemes. And third and first, we will consider non-local problems, one multi-point case, other than integral case. And very important last thesis, identification problems. Identification problem for hyperbolic differential and difference equation, very important, and also we can use these techniques for solving such type of problems. Now we will consider function of positive operator in Banach space. Let f of z analytic function on the set bounded by such f contour gamma s1 s2, and suppose that f satisfied estimate 13 for the sum epsilon greater than 0. That means f of z, absolute volume f of z approaches to 0 when z approaches to infinite. Then operator Cauchy-Riesz integral 15 converges in the operator norm and defines bounded linear operator f of A, such as function of positive operator A. Functions z minus alpha for alpha positive an exponential function minus tz, exponential minus t square root of z. For the t positive, a positive operator were investigated in 8. Since the spectrum sigma of A is closed set, it lies inside of sector formed by the rows S1, S2, and some neighborhood of the apex of this sector does not intersect sigma A. We shall consider contour gamma composite by the rise S1, S and the arcs of circles of radius R centered at the origin, because origin is important. Phi and R will be chosen so that spectral angle less than absolute volume sigma less than pi over 2. And the arcs of circle of a radius R lies in the resultant set rho of A of the operator A. If f of z is continuous and neighborhood of the origin, then in the case we shall consider that R equals 0. And we can put gamma equal S1, S2. In particular, the function f of z, z minus alpha power defines a bounded operator A minus alpha whenever alpha positive. Here contour gamma is chosen with R greater than 0. The positive operators, we can define it as the inverse of this bounded operator. The operator, positive operator, unbounded, they are domains of the domain of A alpha, then say in E, if A is unbounded. One has a continuous inversion domain of A alpha, subset of domain A beta if beta less than alpha. And the following moment inequality holds 16. So the sort of fractional power of operators can be constructed for wide class of positive operator. For such operators, estimate 15 is required to hold for some phi and not only from the interval from 0 pi over 2, but from the interval, a big interval from 0 to pi. Now let us consider function, exponential function minus tz for t greater than 0. This function tends to 0 faster and power z minus alpha as absolute volume z approaches to 0, and its values lies inside any sector bounded by contour gamma. Therefore, formula 15 can be used to define function exponential minus ta of the positive operator. We can show that operator valued function exponential minus ta is a strong continuous semigroup with generate minus a and with exponential deciding norms 17 for some number and positive number. Such way useful for study equation transport neutron and equation such that arise pollution problems at all. So consider later function z minus alpha exponential minus t z for some alpha greater than 0 and t positive. Since obviously f of z approaches to 0 faster than negative power of z as absolute volume z approaches to 0, if z defines operator function 18. We can show the operator valid function is an analytic semigroup with generate minus a with exponentially deciding norm when t approaches infinite, and the for long estimate 19 holders. So here, second case, when we have a strongly positive operator, and so in applications, we can see here parabolic equations. With the help of A, we can introduce functional space such that generate by spaces and domain of A, using by a real interpolation theory. So, but in real applications, PD and numerical results, very important. See here structure of interpolation spaces, because sometimes very useful investigation problem in interpolation space, but rarely for maybe practical useful case when we see our results in concrete norms like L2, like C. So I here put here one reference last our paper, whereas we see structure spaces generated by space of positive fractional power positive operator, and also interpolation spaces and a connection between there, and also some applications. Let A be strongly positive operator. Now we will consider problems such that such that we can use our techniques for solving such problems. And as you see here, there is no local problems. For evolution partial differential equation, we can reduce it at the local and non-local problems. For ordinary differential equation, first problem, this is Cauchy problem for a parabolic equation, Cauchy problem for transport equation. Second, initial value problem for delay, delay type evolution equation, and 22 and 23 here evolution equation with multipoint non-local problem and with integral conditions. And last problem, involutory. So this is evolution equation involves derivative with respect to also maybe with respect special variables in Banach space with positive operator. And as an example, we will consider simpler problem 20, Cauchy problem, and we will consider classical solutions. That means that must be from segments, continuously differentiable from segment T, and VT belongs domain of A, and A VT continues on the segment, and VT must be satisfied initial condition and equations. If the f of t not only continues but also continuously differentiable, and the domain of A, we can prove 25 definite solution our problem. And such type solution refer to solution our problem in the space C of A, standard Banach space of continuous function defined on the 0 t with values E occupied with maximum norms. From existence of the such solution evidently follows Ft from CE and V0 domain of A. We say the problem 20 is well-posed C of if the following conditions are satisfied. Our solution we can see as the operator of Ft and Phi, and is defined which acting from CE domain of A to CE and gives the solution problem 20 in C of E. And this operator regards the CED to the C of E continuous. Here C of E, domain of E A understood as the norm space, pair of f of t and phi, f of t from C of E and phi domain O occupied with the norm 26. By Banach's theorem in C of E, and these properties can be Course-Stiff inequality 27 holds for phi and f of t. So this inequality is called the Course-Stiff inequality in C of E for problem 20. Note that Course-Stiff inequality implies the analyticity of the semigroups. Thus, the analysis of semigroup is necessary for the well-posedness of problem 20 in C of E. Unfortunately, the analysis of semigroup exponential minus S of A is not sufficient for the well-posedness of problem 20 in C of E. We denoted here by C alpha of E, C alpha 0, C alpha 0 T, Banach space obtained completion of the set of all smooth E-valid function in the norms. First, Hilbert space without weight. Second, Hilbert space with weight at the point T 0. And second, here, Hilbert norms with weight at the point T equals 0 and equal T. First theorem, first time proved by Sobolevsky, 1964. And this is first Course-Stiff inequality in this Hilbert space with weight. Why it is important? Because first time he considered problem coercivity in one with respect T for the problem in arbitrary Banach space. E Banach space not connected with space with Hilbert spaces. So initial, but we phi from domain of AFT, this is necessary condition, and then problem 20 is well-posed Hilbert space, C alpha Hilbert space with weight at the point 0, if A is a strongly positive operating Banach space. For the solution Vt, initial value problem, we have Course-Stiff inequality, 28. Now, joined with Sobolevsky, later we understand it is important to consider well-posedness directly in the spaces without weight, but we need some condition for the data. But theorem 3.4 joined with our Sobolevsky more later. 29, we can get, for example, if I put F0 minus A0 equals 0, we get here directly Course-Stiff inequality in the space, Hilbert space without weight. But here we must put this V0 minus A phi from the domain of interpolation space, E alpha. E alpha this is interpolation spaces generated by E and domain of A by these norms. And we can see also coercive inequality, this first order derivative, because phi 0 minus A 0, this is where prima 0 at the point 0. And moreover, the positivity, necessary condition well-posedness, and problem in CE, not well-posed for positive operators. And we must see here some interpolation spaces. And last theorem results proved 17th years by Sobolevsky and Aprata. These results directly we get here under strong positivity condition, coercive inequality in the CE alpha. So I formulate here how we will apply our problem for multidimensional case with no local conditions. So under the smoothness condition, we can formulate here results. Why? Because space operator here satisfied positivity property, and we can formulate our results for the solution such type of problems. And this is a coercive inequality, different type of norms. So this approach allows us to prove the stability wide class problems, linear, non-linear parabolic equation. Moreover, the high order accuracy difference schemes generated by exact difference schemes of Taylor's decomposition on the 2 points for the numerical solution of this problem are presented. Well-posedness of these difference schemes in the Rice-Banach space are studied. The stability, coercive stability estimates in Hilbert norms for solution high order accuracy difference schemes, mixed type of problems for parabolic equation are obtained. Here, reference, and I give here PhD thesis, my students in this region. And second one, when we consider when a positive operator. So this is an elliptic problem. As similar with parabolic equation, we can formulate here different type of problems, and we will consider here classical problems and problems with Samarsky-Bissadze conditions, Samarsky-Yonkin condition, different type of problems. And we will consider classical solution. And here, as you see, for positive operator, functional power has better spectral property such that if A positive, square root of A strongly positive. And for strongly positive operator, that means square root of A generate analytic system groups with estimate 90. And so from 30 follows 1 minus exponential minus t of A bounded inverse case, and 45 follows. And the smoothness condition, we can write formula for solution, and we can formulate here results. First results proved by Sobolevsky in 1964, first coercive inequality for elliptic problem, and next theorem. This is our results shown with Sobolevsky in the space Hilbert without weight, and also coercive inequality C alpha, our results. So, and now we will consider as application one-dimensional case, again with no local condition, and we can formulate here coercive inequality as the theorem 3.10. And so we can consider here general case, linear, non-linear case, high order accuracy, two-step difference scheme generated by exact difference schemes and Taylor's decomposition on the 3 points for the numerical solution elliptic problems are presented. The stability estimates for solution difference schemes can be constructed and application. We can see different type of problems. I here put also thesis as a reference, thesis my students in this region. So here about applications part, joint work with sciences in the field of real-life problems, modern physics, mathematical biology, petrol and gas hydrodynamics, and solar energy permitted me step by step to study more non-classical problems than normal classical problems for partial differential equation. I had joint work with publication with engineering science, Professor Shaja Batyrov, Professor Muradov, Associate Professor Luria from Turkmenistan, petrol and natural gas engineer, Muhammed Köksal from Turkey, electric and electric engineer, Nurlan Arslan, biomedical mechanical engineer from USA, and Zahar Nashet, USA, electronic engineer, and Cem Parmaksızoglu, Turkey, mechanic engineer. So Morava 6 from 36, my PhD students met with me for graduate study, master study and PhD, and they start to work with me after their undergraduate study from engineering faculty, electric and electric engineering, statistics, environment engineering, and mechanical engineering. I am happy to see they made active scientific work in mathematics, and they have position as mathematician in Department of Mathematics. For example, Professor Abdullayev Said Erdogan, Department of Mathematics, Palm Beach State College, USA, and Associate Professor Doğanay Arjman, Department of Mathematics, Uppsala University, Sweden. And lecture Mesut Ürün, Bilimler Akademisi Türkiye. Actually, for applied problems, it is important finding of algorithm. The abstract approach of solution partial differential equation, it is important algorithm to solving several actual problems. Here I consider two reference in collaboration, Muradov and Batyrov and their group scientists. We have been investigating the modeling process exploitation of gas places, the investigation of undergraduate natural gas 6 kilometers under the Earth surface, recurrence and accurate physical description using mathematical models. Unfortunately, these problems typically non-local and ill-posed, and exact solutions are not available. To obtain stable difference scheme, solving such type problems important, and we get some algorithms for solving problems such that involves here in exploitation of natural gas, and we have here some problems. But in this part, when we consider usual way, when consider partial differential equation, we will construct a difference schemes approximation, differential equation and initial data and boundary condition. We get usual system algebraic equation, but dimension very big, because in two-dimensional case, we have two large parameter, n and m, three parameter, and this n m very big, and maybe 100. So dimension of this matter is very big, and usually classical way solving such type problem not good results for large n and m. So very important construction here, high order accuracy difference schemes using by not more points. And here for help, we will consider here approximation theory. So very important here application of approximation theory for construction high order accuracy differences can using by only maybe 2 points. So Taylor's decomposition on the 2-3 points is very important for getting such type results. I consider here Taylor's decomposition on the 2 points. As you see here, this Taylor's formula is generalization of Taylor's formula, but for getting approximation order or small tau, p, and q, we need Taylor's formula with summation per q. But here we get 2 sum, not more p and q, per q differently. So this is important for construction high order accuracy differences. By the way, these coefficients Pada approximates exponential functions. Why? Because again, we constructed for the solution parabolic problem. We constructed using by exponential function. Here for construction also we will using approximation exponential function. Next theorem, Taylor's decomposition on the 3 points, but here same. We have formula for construction high order accuracy difference schemes, and this coefficient is not clear, but it is a combination, some approximation of sinus and cosinus. Why? Because usually it is also it involves from viewpoint of solution. It is constructed by cosinus and sinus operator functions. Here, all we will using same idea. So Taylor's decomposition of 4 and 5 points numerical solution, high order approximation, compact finite difference schemes of linear OD and PD is not well investigated. In the paper 13, 15, 3-step difference schemes of first order approximation generated by Taylor's decomposition on 4 points on numerical solution, non-local, local problem for third order ODE PD investigated. Application of Taylor's decomposition on the 4 points for numerical solution, third order, time varying linear dynamical systems was presented. The method was illustrated for the numerical solution of an up converter used in communication systems. Here a reference about it. Inverse problem have a significant role in natural science, applied science, engineering, quantum mechanics, diffusion equations. Some reference. Operator approach for solving partial differential equation permit us to study several actual source identification problems. Here some reference about application operator approach to inverse source identification problem for parabolic equation, first and 2, and second Schrödinger equation. Third, mixed type of equation. Next, also investigation this theory for study identification problem for mixed type of problems. And next one about application this theory for the study system nonlinear parabolic equation observing epidemic models with general nonlinear incidence rate. So we will consider here all some theoretical part and also investigation our problem, such type of problems. And last problem joined with my colleagues from engineering science and my student, an important part of energy consumption occurs in building energy efficiently building design is a design that reduces the energy issues and pollution controls and criteria. Architectural building design roles and functionality, stability, aesthetic. This study gives a mathematical model of the time-dependent energy conception calculation problems. Well-posedness in Hilbert space of mixed one-dimensional parabolic problem with certain boundary condition considered, the dynamical model results uncomputed with the numerical results. Now about my investigation online in future, I invite you on the behalf of the organizing committee of the International Conference ICAM. The aim of ICAM is to bring mathematician works in the area of analysis, applied mathematics together to share new trends, applications of mathematics. In mathematics, the development in the field of applied mathematics open new research areas in analysis and vice versa. That is why we plan to find the convergence series providing forum research and science communicated the recent results and present the original results in various fields of analysis and applied mathematics. The ICAM conference are organized biannually. Provides conference were held in Gümüşhane 12, Chimkent 13, Almaty, Kazakhstan 16, and 18-20 Mersin, Turkey, and 6 ICAM was held in Antalya, 22 cooperation with Department of Mathematics, Bahçeşehir University, Istanbul, Turkey, Analysis and PD Center, Ghent University, Belgium, and Institute of Mathematics and Mathematical Modeling, Almaty, Kazakhstan. The procedure of extant abstract of all ICAM 1222 were published in IEP, American Institute of Physics, conference proceeding. Moreover, papers of participants were published in several special issues in CG journals with impact factors. Moreover, you are accordingly invited to the weekly online seminar, Analysis Applied Mathematics, on Thursday in cooperation with Department of Mathematics, Bahçeşehir University, Istanbul, Turkey, and Ghent University, Belgium, and Institute of Mathematics, Modeling, Almaty, Kazakhstan. Here you can see all abstract and forthcoming talks and video presentation of all speakers can be found on our web pages. The proceeding of the extended abstract of weekly online seminar will be published in IEP conference proceeding. And now about master for young sciences, master program and PhD program. All three of my organization give importance to graduate and postgraduate study in sciences, basic branches in the words, master and PhD program. As you see, there are two equivalent system, education system, diploma work, candidate sciences, doctor of science, master science, PhD, postdoctoral. So here some publications, journals, indexes, scopes, and Web of Science, and from least high attestation committee of Russian Federation and former Soviet Union. So we have also a journal, electronic journal, Analysis Applied Mathematics, and international journal dedicated latest advances of analysis applied mathematics. The goal of the journal is to provide a forum for research science, communicated their recent developments and present their original results in various fields of analysis applied mathematics. We are also interested in short papers, clearly address specific problem, and short service or position papers that sketch of results, problems, and specific topics. it is continuation of our journal, Complementary Analysis and Applied Mathematics, was founded by university and from a list of journal of Turkish Higher Education and High Attestation Committee of Russian Federation and former Soviet Union. You are welcome publish in these journals. Thanks for your attendance. This is the end of my talk.
Thank you very much, Professor Ashyralyev, for this very valuable and insightful talk. And I'm sure the colleagues, those who have the background in maths, had critical insights into your work. And thank you for presenting this, the role of positive operators in their applications. So I would like to open the floor for Q&A, but since despite my different notices, we do not see any questions in the chat box, but still I will invite anyone among the participants to, if you have any questions. And as far as Professor Rijali's comment is concerned, he has thanked you. He has thanked Professor Ashyralyev for accepting the invitation. And he has highlighted that some of the critical or important applications of the theorems that you mentioned. It could be how could they solve engineering problems? Of course, you highlighted, for instance, gas engineering, especially the gas deposits discovery. These theorems could be useful, and some in solar energy and also the energy efficiency buildings. For general audience, what are the critical limitations? For instance, we see there's always a limit to the efficiency of engineering products. For instance, there's a limit of efficiency. There's a theoretical limit of efficiency in the, for instance, a petrol car or diesel engine. How do you address improving the efficiencies of engineering systems using these theorems? So this is just my generic question.
Okay, but it is dependent with object. As you see, when I meet with people, natural and gas, I try finding maybe some understanding point for solving their problems. And every time we will construct it, maybe theoretical techniques for solving problem. If you see a last problem, save energy, it is important. Last problem, and when we talk long time with Cem Parmasoglu, we understand very important construction numerical solution for solving problems such that arise it. But when I see this is parabolic equation, and we will see parabolic equation, but problem like that must be solution of parabolic equation must be not dependent with t, because save problem energy. But usually property of parabolic equation, when t approaches t infinite, we get solution of standard problem, elliptic problem. So this is when t approaches infinite. But here problem such that must be not dependent with t. So we will consider some algorithm, but usually they use it program very expensive, and when they put data of Turkey, this program not good working. So we must see our problem under the data given in Turkey. So we will consider our algorithm for solving such a problem, and we will I formulate here our results joined with these persons. By the way, when I meet electric engineering, Doğanay Arjman and Muhammed Oksal, also they said 30 years many scientists work it in this area, but use it integral transform and when coefficients not dependent in T. But construction high order accuracy important for getting results when dependent in T. But usually it is third order ordinary differential equation, not difficult problem. You understand? How we constructed here exact solution? No way. No exact solution. How we constructed high order accuracy difference schemes? Why we start joined with Arjman? He was student Boğaziçi University electric engineering department, not mathematics. And later he understand powerful techniques, not electric engineering from math department. And now he is a professor, associate professor in Uppsala as mathematicians. And this is important. Now Uppsala, Doğanay Arjman working not via point of math, all time via point of practice, finding new name, maybe solution, new problems. You understand why it is important? Joint work. But every time it is dependent with a normal subject, not general concepts. Why I have some difficulty for choosing subject for talk? It is not easy. And organization, why not easy? But starting point, it is important, Khalid. But if you think maybe continuation long time, it is not easy. You understand or not?
Right,
so
right.
Because this is middle point, must be powerful help from other science, not mathematicians, also engineering science. But everybody must talk problem and problem with understanding this problem via point of math, with techniques. You understand or not?
Understood that, there are physical, boundaries and limitations and the problems that we are trying to address through our engineering systems, and the theories and the theorems, models, equations that you presented. They are the tools to address, and if we understand the extent of to what extent we can achieve the sustainable results using those theories. And I have now one question in the chat box from Professor Ismail Babolian, and he is a representative of the Kharazmi University, and also he's a member of the executive committee of the UISMS and USF executive committee for organizing this lecture. So he has asked, is this theory applicable to the Fredholm integral equations of the first kind?
Inverse problem, identification problem if you start, but it is inverse problem. And usually if you see via point of inverse, this is Fred-Golomb first type equation, and so directly. But all time, but we have some not published paper with joined Professor Said Erdoğan, construction new techniques for solving incorrect problems, ill-posed problems, and we see Walter Fred-Golomb time first order. This is a very important subject. So, but all time you must think about maybe not directly construction, understanding how we will apply it. it is only maybe better results joined, not usually find book and formula and apply your techniques. This is my idea because I met with different people, different region, and I understand all time I met with difficulty for solving, for starting problem.
Right. I think now, thank you so much for your very valuable responses to the queries and the comments at the end. Now I would like to request Professor Komel Tayyebi, the president of the ECO Science Foundation, for his thank you note. Over to you, Professor Tayyebi.
Okay, Khalil, you hear me, Khalil? Okay.
Yes, perfectly. Thank you.
Right. Okay. I would like to express my sincere thanks to Professor Ashyralyev for very wonderful presentation in this time. Thank you very much, Professor, for accepting our invitation for this session of the lecture series. Fortunately, the monthly webinars on mathematics and science in cooperation with the Ecoscience Foundation and also Union of Iranian Societies of Mathematical Science, UIMS, has been so successful and has been fruitful to our participants, and every month we will have such great webinars. And the main purpose of such events or to exchange ideas, exchange, for more communications. And of course, this is the advantage of such webinars. Once again, I'm very thankful to you, Professor Ashyralyev, for your such great presentation and such applications. I'm sure people have enjoyed your speech for this session. I would like to thank to UI MS and also the EcoSF team, especially my colleague Khalil Reza, for this having and holding these great webinars. Dr. Professor Sumbro in the chat box just pointed out, the importance of of mathematics for different applications. As my major is economics, for some complicated theory, we use mathematics to explain and to understand, to find out of the purpose, of the goal of theory and the principles of the economic theory. That's very important. And once again, thank you very much. And I would like to thank to all participants for this session. Khalil?
Thank you, Professor Tayyebi. Thank you, Professor Ashyralyev, once again. And for the, you mentioned the conference, the upcoming conference on ICAM. You can share with us the details. We will post it.
Yeah. I will send you this my presentation for you. I think you can find.
Yes. Okay. And we'll post that the details of the event.
Also, social media. Weekly hour seminar. It is important because similar organization also we have in Bahçeşehir University. Not easy, really not easy, but this is a middle point. Analysis and applied mathematics not easy. So this, in your case, very large and really not easy.
Yeah, rightly put.
For example, here one dissertation graduated this year, stochastic parabolic equation, as you see, directly involves in problem of financial mathematics. So no talk about such type problems. So I have here a lot, maybe you can see a lot, maybe investigations such that arise in different fields, financial mathematics, economics, et al. But I try give operator approach for solving different type of problems.
Right,
Okay.
absolutely. And we look forward to collaboration in the future as well. We are grateful for your valuable time and considering for participating in our webinar. And we try to host at least one webinar every month, especially focusing on mathematics. And the idea is to build the knowledge base, the network of mathematician scholars to help curate the interest among mathematicians, and also for the young students who are at this edge where they are opting for careers, and perhaps the science, technology, and maths is one of the areas that they can be inspired with the contributions like that you mentioned. So thanks all. Thank you, everybody.
Thank you.
And
Thank you very much, President.
this brings us to the conclusion, and we look forward to your continued participation and collaboration in the future as well. Have a very good day. Bye-bye.
Good day. Bye-bye.